record. Okay, so we have isobaric, isovolumetric. We also have isothermal. And the last one is adiabatic. Okay, can you guys tell me what are the constants for each thermal processes? Apa yang constant for isobaric?
Pressure.
Pressure. Okay. Iso means same, bar means pressure. Isovolumetric,
Volume.
volume. Okay. Isothermal,
Thermal. Temperature.
Temperature.
adiabatic,
Q.
Q,
The heat.
energy,
Q is
zero. Okay, so
The change of heat.
the change of heat, yes. So all these thermal processes has to have something that is constant. So if you look at the word, if you come across a thermal processes, the first thing that you should do is what is constant, and then only you proceed with the question. You need to identify what is the constant for that thermal process. So that's your first step. And then if delta P is zero, and usually for isobaric, we know that W equals to minus P delta V. This is the usual equation because pressure is constant for an isobaric. Okay, this is delta P equals to zero. It doesn't mean P equals to zero because P is constant. P final minus P initial is zero, which means that P is constant. So there is a value. It's not zero. Walaupun saya tulis delta P equals to zero. Sorry. And now we have isovolumetric. I should use a different color. Isovolumetric, delta V equals to zero. So what becomes zero as well because of this?
The work.
The work done, right? Work done becomes zero. So minus P zero is just zero. Okay, so this makes our equation delta U equals to Q plus zero, which is just Q. Okay, and then we have isothermal. I told you isothermal is a little bit confusing because delta T equals to zero does not mean that Q is equal to zero. It does not mean the same thing, which means that you have Q, but the temperature is constant. So if the temperature is constant, what else is zero?
Volume.
No, it's not.
Changing internal energy.
internal energy.
So sorry.
Delta U is okay. Delta U is equal to zero because delta U is related to it's F over 2 NR delta T or NCV delta T. So you have the delta T here. If delta T is supposed to be zero, then your U is zero. Okay, but remember it does not mean that Q is equal to zero, even though the temperature is constant. This is something very, very important and often makes people confused. Okay. And then the next one is adiabatic. Q equals to zero, which means that there's nothing going into or out of the system in terms of heat energy, which makes our equation delta U equals to your Q is a zero and you have W. Okay, so whatever equation that you decide to use for W, just use it. Okay, so what are the other variations for equations? Ada lagi tak selain daripada ni? Variations in equations. Let's use purple. Let me group that. Can anyone remember the variations in equations selain daripada apa yang kita sebut ni? Kita belajar semalam in our exercises.
And RT ln V2 over V1.
Yes. So that is for isothermal or isovolumetric?
Isothermal.
Isothermal. Kenapa? Why is it for isothermal and not isovolumetric? How do you guys decide? I mean, you come across this question, you don't remember which thermal processes. How do you define what is a thermal process? Okay, that's like weird. Okay, kita tulis dulu. nRT natural log V final over V initial. Okay, so you said it's supposed to be isothermal. Why? Based on this equation. So what is changing in this equation? What changes?
Volume.
The volume changes. Okay, so confirm isovolumetric is not it lah. And then we have T. T does not have a delta there, so T is constant. So yes, this equation applies for isothermal, and this is for the work done. Okay, and we are missing a negative sign. Sekejap, let me write that back. So ada dua benda yang ada negative sign for work done on gas. This is the first one, W equals to minus P delta V. The other one is W equals to minus nRT natural log V final over V initial. Okay, it's a minus. All the equations that we are talking about here is about work done on gas. Okay, which kan ni? Kejap. Oh. So all of these equations are work done on gas. Okay, so work done on gas. So if I wanted to like find out what is the work done by the gas. Okay, so that kita tulis warna lain. So work done on the gas is not equal to work done by the gas, but it is equal to work done on the environment. Because why? Because kerja dibuat oleh gas kepada on the environment, right? If the environment is doing work, it means that if work is done by the environment, work is done on the gas. So this is equal to work done by environment. These are just terms, eh? So you just need to remember what does by mean, what does on mean. Okay. Is that okay for everyone? Okay, so let's talk about work done, W for this guy. So we talked about W equals to minus P delta V, and this equation applies if I'm talking about the gas system. So, so if my gas system is expanding, okay, kita tahu when it is expanding, negative work is done on the gas, and when it is compressing, positive work is done on the gas. But if I ask you, what is the work done by the gas? Maybe I should do this in another slide. Dah just serabut dah kat sini. Sekejap give me a minute. Let's talk about the expansion and compression. Okay, so let's draw. Forgive my drawing as always. So this is my strange, okay? So I have expansion and I also have compression. Okay, so this is expansion and this is compression. Okay, and then I want to know what is the work done. Hey, loading dah. Okay, what is the work done on the gas? I know that when my gas expands, my gas is actually pushing the walls, which means that my gas is actually doing work on the environment. So work done on the gas is negative, but the work done on the environment, on the gas is negative. Sebut negative, tulis positif. Work done on the environment is positive. Work done by the gas, can you guess? Is it positive or negative?
Positive.
Positive, because I said work done on the gas is negative, which means that work done by the gas is positive. It's doing work by the gas. The gas is doing work. Okay, so that is for expansion. Okay, sorry. Don't know what's wrong with my throat today. Kita group jap, kita kecilkan sikit. Okay. So sama juga at compression, start with what we know. Kita belajar pasal work done on gas. So compression, we know that work done should be positive. Let's start with something that we are familiar with. Work done on gas. This is a negative change in volume. This is positive change in volume. So work done on gas, I told you negative change in volume always means positive work. This is for work done on gas, which means that work done on the environment is negative and work done by the gas is a negative. Dia terbalik je. So work done on the gas is negative, work done by the gas is negative. So let me write that down. Work done. So macam mana nak ingat semua benda ni? You start with the equation W equals to minus PV. This is for on the gas. You just remember this equation. If they ask you what is the work done on the environment, what is the work done by the gas, it just means negative of whatever that you get. Okay? Just remember one equation, work your way for environment and by the gas. Just remember on the gas system punya equation sahaja. Okay? So I hope I cleared confusion. Everyone okay? Aliana, Umaira, you have a question? Are you okay? Is everyone okay? Does everyone understand? Nobody understands?
Yes.
Yes.
Okay, doctor.
Okay, all right, that's good. Kalau confused, you can discuss with me or you can try to discuss with your friends and see if that helps, or just watch my video balik. Okay, so let's start with our first exercise. A gas is compressed at constant pressure. So immediately I know that this is an isobaric problem. Isobaric thermal process, which is delta P equals to 0 of 0.8 atm. So P is equal to 0.8 atm, which means I need to convert this to my Pascal. So 0.8 times 1.012 times 10 to the 5 is 8960 Pascal. From 9 liter to 2 liter. So this is initial, from initial to final. So V is, the change in V is V final minus V initial. V final is 2 liters, V initial is 9 liters. So this gives me 7 liters minus. How do I convert this to meter cube? Does anyone know? I can't use this in liters. It's not the SI unit.
0.001.
0 times 0.001. So
Yes.
Umar. Okay, thank you, Umar. Let's try minus 7 times 001. Betul ke, Umar? Divided by
Another 0.
another 0. Okay. So it's times 0.001 or, betul, or we can do it this way. 1000 meter cube, terbalik. 0.001 meter cube, which is what Umar said, over 1 liter. This guy is liter, cancel it out. So 7 times 0, okay, 7 times 10 to the minus 3. Betul tak? Okay, betul. Meter cube, negative. Okay, so if multiplying by 0.001 confuses you, you can use this method, which always helps me. If not, just use whatever method that you feel comfortable with. Just know that how to convert liter to meter cube. Okay, moving on. Meter in the process, 1,400 joules of energy leaves the gas by heat. Leaves. Should my Q be positive or negative?
Negative.
Negative.
Negative, because it is leaving, right? It
Release.
is expelling, it is leaving, it is releasing. So dikeluarkan. So 1,400 joules. what is the work done on the gas? Okay, kita baru buat conversion, etc. Now it's time to answer the question. So let's group this. Ooh. Okay. Let's use blue. Okay, so work done. What is the equation that I need to use here? It's an isobaric, so what is the work done equation?
Negative P V.
You're missing something. Negative P,
Delta V.
Delta V.
Thank you, Zafira. Thank you, everyone, for helping. So, negative P delta V. Okay, great. So we know what our P is, minus 8,960, and our delta V, we already have that, minus 7 times 10 to the minus 3. Now here our delta V is a negative change in volume, which means that it is compressing, which means that our work done on the gas should be positive. This is our, what do you say, insight lah, sebab kita dah belajar kan. Kita ada knowledge lah. So I'm going to say, okay, maybe the work done is positive. Let's see. It should be, sebab ada 2 negative kat situ. So the answer is 8960 times 7 times 10 to the minus 3. So that will give me 566.72 joules. So that is the work done on the gas. So tanya on the gas. If the question says, what is the work done by the gas? I should have a negative here. I said, whatever answer that you get on the gas, by gas should be negative. Negative of work done on gas. Okay, so if you get a positive here, work done by gas is a negative. Work done on the environment is a negative. Okay. B, what is the change in its internal energy? So this is easy. What is the equation here? Equation.
Q plus W.
Q plus W. Delta U is equal
Delta
to
U.
plus, yes, Q plus W. Thank you. So that is Q, we know that minus 1,400, and we already solved for our W, which is positive 566.72. So our change in internal energy is actually a negative, which means that it's losing energy. It's losing energy. So dia penat lah. Gas ni jadi penat. So let's see if the answer is correct. Yay, we solved it. Okay, great. Positive, W, negative, change in internal energy. The gas loses energy, becomes tired. Okay, not really lah, gas is not alive. Okay, next question. A sample of gas expands isothermally. Isothermally, what should be constant here?
Temperature.
Temperature. Thank you, Zafira. Delta T equals to 0. And thus 4 times 10 to the 3 joules of work in the process. So should my W becomes positive or negative? Should my work be positive or negative?
Negative.
Negative.
Negative because
Work done by the gas.
work done by the gas. Where does it say work done by the gas?
Expands.
Expand. Expand. Yes. The word expand means by the gas. Betul? Okay, so the word there expands means that your work is negative. So minus 4 times 10 to the 3 joules. Find the change in internal energy of the gas. So what is our equation to use here? Anyone wants to try? Ada banyak equation delta U. Which one is it? One? Okay, saya panggil Hikmah. Are you there, Hikmah? Hello, Hikmah. Hikmah is not there. Ke saya pause? Tak, saya tak pause pun. Okay, Hikmah is missing. Oh my god. Tolong cari dia. Can I get nut mango?
Yes, doctor.
Okay. Sorry, I hope you don't mind me calling you nut mango because it's cute. Okay, delta U punya equation apa?
If isothermal is delta U is equal to 0.
Yeah, correct. Betul?
Oh,
What is
oh,
the equation if I wanted to use an equation?
If wanted to use equation,
Mhm. If I don't
but
if it's I don't remember it's 0 and I want to use the equation, which equation should I use?
Q, how do you say?
Who wants to help? Nat?
Is it, can we use NRT?
Yes, boleh. So what's the full equation for NRT though?
What is that? NR delta T.
NR delta T. You're missing something here.
Ne, F, FO2?
F over 2. F over
Is
2.
it FO?
Yeah, betul. F over 2 NRT.
Okay.
Okay, so if I don't remember that isothermal, thanks Nat Mango. If I don't remember that isothermal is supposed to have an internal energy that is 0, then I can use F over 2 NRT, NR delta T or NCV delta T. And I figure out, okay, delta T is, it should be 0. So this will give me a 0. Okay. If you wanted to use Q plus W, you can, but it doesn't help solve the, does it help it? Does it help? Kejap, let me think. You only have W, you don't have Q, so you can't really tell what is delta U. So no, you can't use this one. Okay. So delta U is equal to 0. That is the final answer for A. Moving on to B, thanks Nut Mango. The heat absorbed by the gas. So we have our equation delta U equals to Q plus W. We have our W, we have our delta U. We want to know what is the Q. So 0 equals to Q minus 4 times 10 to the minus times 10 to the 3, which means that my Q is just equal to 4,000 joules. So what does it mean here? It means that when I absorb 4,000, my gas is absorbing 4,000 joules of heat, Q. The gas expands and does work. So negative W. Okay, so that is your...
Doktor,
Yep.
nak tanya,
Mhm.
yang ini work by the gas ke work on the gas?
Work by the gas because it expands.
Jadi kalau work by the gas, kalau expand should be positive kan?
Work by the gas should be positive.
Kalau expand.
Okay, let's look back at our apa? Okay, kalau expand, work done on the gas is negative W. But soalan dia tanya by ke? Soalan dia tanya on kan?
Macam on. Saya tak confused.
Dia tak cakap by the gas. There's no word. Soalan dia tanya, okay, the change in internal energy of the gas and the heat absorbed by the gas. So kat sini dia tak cakap, okay, what is the work done by the gas? So dia tak cakap by the gas ni. So we are going to have everything on the gas. Faham tak Umar?
Okay.
So
So it should be work done on the gas.
Yes, the default state is on the gas. Betul.
Thank you, Doktor.
Alright, you're welcome. Did everyone understood what Umar was asking? Okay ke? So everything, when you start with your equation, selagi dia tak sebut what is the work done by the gas, you assume that everything is work done on the gas. We are talking about work done on the gas. Sebab semua equation yang kita belajar is work done on the gas. So that is your default. That is where you start. Unless the question says, what is the work done on the environment? What is the work done by the gas? Then you have to like include the negative sign somewhere. Okay, default is on the gas. Okay, so that is my that is correct. We got the answer right. Okay, betul, betul. Okay, moving on. Okay, let's do this together. I'm going to give you guys 7 minutes to do exercise 15.3, and then kita akan do that one first lah before exercise 15.4. Do we have time? Yes, we do. 7 minutes, so 10:37. Sebenarnya 7 minutes is too long. Okay, so I'm going to call someone randomly as usual to help me. If you guys finish 15.3, please proceed to 15.4. Oops. Oops. Hmm. Okay, so for the first one, I want Afrina. For the second one, can I get one Fatihah? Okay. Da-da-dum, she's nervous. Okay, so apa, Afrina and one Fatihah. The rest of you, please try doing it yourself juga. This is part of your exercise. Okay, Afrina, are you ready?
Yes, Doktor.
Okay, boleh. Boleh kita mula?
Boleh, boleh.
Okay. So how did you start? So isovolumetric,
F over 2
okay, F over 2
NR delta T.
and R delta T. Okay,
Lepas tu masukkan dia punya 3/2,
3/2. Okay,
3,
3, 8.
8.314,
Okay.
40.
Okay,
Lepas tu dapat 1496.52.
96.52 joules. Yang ni apa, Afrina? What is this?
Delta U.
Delta U, okay. Okay, so this is delta U. So what is the heat added to the gas? Okay, Afrina, are you there? Okay ke tak tu? So,
Yes, Doktor.
heat, macam mana awak kira heat? Apa equation untuk heat? Isovolumetric. Q equals to, ingat tak? Ada CV, CP, N, tak ingat? Okay, it's N, CV, delta
Delta T.
Okay. So why, so jawapan awak ni 1496 ni, is it the answer? Okay, pasal sama. Okay. So if you look, delta U and Q is the same. Sebab apa Sebab ni sama juga. CV is equal to 3/2 R delta T. So Q and delta U is the same. Why?
As the work
Hmm,
is 0.
Because the work is 0, betul. Isovolumetric delta V is 0, which means work is 0, which means delta U is Q. Okay, so betul. Afrina buat ni betul, but Afrina tak faham that it is actually heat juga. But good try. Did everyone understood what was done here? Faham tak? Everyone okay?
Yes. Faham.
Okay. Tak faham? Zafira tak faham?
Faham.
Faham. Okay. So sama je jawapan dia, delta U is equal to Q. But if I may suggest, Afrina start with tengok thermal process, finding out what is the constant here. Constant is delta V equals to 0. And then if delta V equals to 0, what else becomes a 0? You start with this process first so that you know what you are doing. Okay, so that is my suggestion. Okay, next one.
okay.
All right. Thanks, Afrina. Next one is one Fatihah. No, dia pun tutup. Okay. Okay, sama. Okay, so one Fatihah. Should I call you Fatihah or what?
Fatihah.
Yeah. Okay. So how did you do this one?
Saya guna equation Q
Hmm.
equal to NCV delta T.
Okay.
Okay, saya pun susun balik dia punya equation tu. Masukkanlah kan. Jadi saya dapat, tapi sebelum tu kena cari yang CV.
Kita cari CV, okay. Your CV.
Okay. Okay, CV tu saya cari 3/2
Hmm.
darab dengan 8.314. Okay. Jadi saya dapat 12.47.
Okay.
Okay. Saya pun masukkan dalam equation tu. Q 650.
650.
Okay. N 3, mol 3.
Hmm.
CV 12.47 dengan delta T. So delta T saya dapat 17.37 Kelvin.
12.37 Kelvin. Betul ke? 12.37?
17.
12. Macam mana? Berapa? Sorry tak dengar.
17.
17 Kelvin.
17.37 Kelvin.
Oh, okay. Alright, thank you. Is that the right answer? Saya tengok balik. Tak tahu. Okay, betul. So let's see how she did it. Thanks, Puan Fatihah. Okay, so 650 of heat joules are removed. Q is supposed to be negative from 3 moles. So N equals to 3. In isovolumetric, delta V equals to 0. W equals to 0. What is the change in temperature of gas? So here we already know that delta U is equal to Q because W is 0. So so Fatihah terus pakai Q equals to NCB delta T to find out what is the change in temperature, which is correct. And then she solved for CV first, U/2 times 8.314, and she got this. This is the units, okay, joules per mole dot K. And then she substituted that into the equation and solved for delta T. Okay, dapat betul So,
Doktor, untuk Q tu kita kena buat negatif ke tak?
oh kena, betul. We missed the Q. We missed the negative.
Kalau buat negatif, final answer
Dapat lain.
negatif.
Sepatutnya dapat negatif juga lah kan.
Tapi
So-
skema punya answer tu positif.
Okay, dah kita tengok Thanks Umar. So negative 650 remove negative, so negative delta U equals to negative Q plus 0. Okay, so it should be negative. So negative 660 joules equals to 312.47 delta T. I should get a negative delta T. So tak, because there is a negative here. So delta T is sama juga tapi negatif. Kenapa dia dapat negatif positif Tengok sekejap. I think the answer should be negative. I will check back on this one. Okay, thanks Umar. So I will make a star over here and I will get back to you on this one. Okay, so that is it for our class today. Habis dah on thermal processes. Next one, it will be on second law of thermodynamics, which is on heat engines and heat pumps. But I don't think we should do it today. Sebab macam sekejap sangat and saya kata kejap-kejap and it will not be enjoyable for both of us. So let's just end it here. So any questions before we end class? We have 15 minutes. Any questions that you want to ask aside from this one? Any? Kita ada keraguan di sini. Any other questions? Everyone doing okay? Everyone understood what was going on? Why we discussed that this guy should be negative instead of a positive?
Yes, Doctor.
Because heat is removed, heat is removed, Q is negative sepatutnya. Any other questions? No questions? No jokes? No nothing? No update? Okay, all the best for your Muet. Is that how you pronounce it? All the best for that. Take care and stay safe. I'm gonna stop sharing. Bye guys.
Thank you.
Bye-bye.
Thank you,
For us,
Doctor.
Doctor.
Thank you, Doctor.
Thank you, Doctor.
Doctor.
Thank you, 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 Doctor.
Welcome.
Thank you, Doctor.
Bye, Haikal. Welcome. Inshallah. And quiz, yes. Okay, welcome Nurhan. Bye Redo. Lama tak dengar suara Redo. You're welcome Nick. Okay je insyaAllah. Nanti kita buat revision next week. Okay, don't forget to do your website. Nanti kita akan discuss kalau ada tips ke apa ke sebab saya tak tengok soalan lagi. Soalan dah siap, saya tak tengok lagi.
Thank you, Doctor.
Welcome. Tak nak balik ke? Cik tak nak balik. Padahal kat rumah je. Bye. I'm gonna end now. Take care.